everybody, and welcome to another OpenShift Commons briefing. This week, we have Dennis Glatzkik from OutCloud Solutions, a longtime Splunk person, who is going to talk about monitoring OpenShift and Kubernetes with Splunk Enterprise and Splunk Cloud, which makes me very happy because we get to introduce OutCloud Solutions as a new member to OpenShift Commons, and we get a talk about Splunk, which is one of his big expertise areas. So, Dennis, thank you for coming today, and please do a better introduction of yourself and your background, and let's get started.
Thank you, Dion. Yeah, so first of all, thank you everybody who joined us today for this webcast, and at the same time, I just hope that we will give some information about the Splunk, what the reason why it would be interesting to using Splunk to monitor OpenShift. Also give you an overview of our solution. So before we get started with the demos, let me actually introduce myself so you'll know some story behind our company and what we do. So a little bit myself, actually in software development from 2005. I work on various tools like development tools, various services, even mobile developers, but my passion was always about the DevOps tools, like developer tools and operation tools as well. I work in Microsoft, Splunk, and Stripe as well, and used a lot of various languages and platforms. So you can find me on outcoldman.com and my username and Twitter @outcoldman as well. So as you can see, there is some familiarity with the name of the company, OutCloud Solutions and OutColdman. I will get back to it in a second. So in 2013, I actually joined Splunk, and I was a Splunk employee for a while. In 2015, just out of curiosity, I started to look at the Docker, and one of the things I was curious about building the Splunk image in Docker. And so this is what I did on my free time after this, work a little bit on Splunk login driver for Docker. And meanwhile, I actually work on a lot of things integrating Docker in Splunk. For example, we use it for development workflows, for some other things, but in 2017 I left Splunk, and again, like out of my curiosity, I started to work with Kubernetes and build this first prototype. I mean, I found that I was really interesting to find a way to monitor the Kubernetes in Splunk, and so built my first prototype of monitoring Docker and monitoring Kubernetes in Splunk. In November, we found that it's actually not only we who are actually interested in that, and there are some customers who want to pay for that. And so I found the co-founder, and we decided that in December that we should found the company and start working on the solutions for monitoring OpenShift, Docker, Kubernetes in Splunk. And as you can see, this OutCloud Solutions, we just use this name because there was some work already was done on my nick OutColdman, and we decided just to use it so people they will see us, they will see some history around who is working on this and so on. So OutCloud Solutions is the company that provides the monitoring solutions for OpenShift, Kubernetes, Docker, Splunk Enterprise, and Splunk Cloud. We are providing the solution for Windows and Linux containers as well. And we are proudly tell that we actually Red Hat technology partners, and we at the same time Splunk technology partners. So let me actually now go to the one of our solutions. I'm mostly going to talk about monitoring OpenShift, but our solution for monitoring Kubernetes is pretty much familiar. There's a few things different around the kind of giving native experience. Like for example, in OpenShift, namespaces are called projects, so we're trying to keep it this way. But in the Kubernetes, we call them namespaces and so on. So what's use cases for using our solution? First of all is application monitoring. We actually forward all the information about the metrics from the processes, containers, all the information about limits. If you limit your workloads in the OpenShift, we forward containers and application logs. And log aggregation is another use case when you actually want to get all the logs from containers, from the hosts and application logs, or something more specific like audit logs from the master nodes as well. Another thing we do is we're helping you to monitor the health of the cluster. The things, how well is what's the current status of capacity planning, how well you actually managing the capacity of your cluster, some guidance about security, which containers running with the root privileges or with elevated security permissions, something like that. We also give you an overview of your control plane, etcd cluster, Kubernetes API server, and so on. So I will show you a demo on this as well. Some broader benefits. It's built specifically for Kubernetes and OpenShift, so it's ready to use. It's 10-minute setup. Just literally takes 10 minutes to actually get it up and running and get pretty much all the data we will show in the demo in Splunk. It's a certified solution, so we're actually working with Red Hat to certify a solution like the server-side piece. It's like our Kubernetes native application that pull all the metrics, data, and everything and forward to Splunk. And our application certified by Splunk, so working with them as well to make sure that we are providing the really well and supported applications. And at the same time, if you're already a Splunk customer, then you can leverage your Splunk Enterprise or Splunk Cloud infrastructure. Or if you're not Splunk customers, Splunk is really useful for and really powerful in the sense of reviewing the logs and like having correlation between logs and metrics. You can also build some custom dashboards, basically custom application solutions on top of Splunk. Basically, for example, what we did. You can actually set up project or cluster level access control list. I will show you a demo on this as well. So what's about installation, how long it takes? The only thing we actually require at this point is we ask to make sure that you're using JSON login driver as default login driver for Docker. And I mean, it's pretty much everywhere you'll find it's a recommended way as well. So there should not be any issues with that. So in Splunk Enterprise or Splunk Cloud, you will need to enable HTTP event collector. And this is only one thing about Splunk is that we actually have a requirement on Splunk version 6.5. It's where the HTTP event collector has all the features we need. But we actually can support the earliest version of Splunk. It's the only one thing we need to make sure that the forwarder, which we actually will take all the data from our collector, will have at least version 6.5 or above. You will need to install our application from the Splunk base. It's, like if you're not familiar with Splunk base or Splunk, basically like an app store, you go, you find the application, install it, and that's it, you're done. And after this, you can download our predefined configuration. We have one Alpine based for, like for example, people who use Origin, and another one is Red Hat based images, certified images from the Red Hat registry. If you're a Red Hat customer, you will want to use that. And we support OpenShift starting from 3.4. So after you download our configuration, basically the three things you need to do: accept EULA and set the URL where your Splunk is, and define the token. And token is basically the way how you can secure your endpoint to make sure that nobody else will try to send some data on this endpoint. And after this, apply the configuration and give our user privileged access. The thing is, I mean, you can work around it as well, but like in most cases, when users are not familiar or don't have a time to actually define a much well-grained control. So first thing, we need to make sure that we get access to the log files, and usually they're written by the root user from the Docker daemon or something. And another thing, we need to trace admin security privileges on the Linux boxes to get the information from the metrics and so on. So there's some things which are required, and this is the easiest way. If you want to work around this, you can talk to us, and we will give you the better way to do that as well. So after you deploy, what we do, we deploy 2 daemon sets, one on the master nodes where we collect all the logs, all the metrics, and also information from the control plane, like from controllers, API server, etcd cluster if you're running etcd on the masters. Another daemon set is for the other non-master nodes where we don't need to collect the a control plane metrics, so we basically just collect the host, all the logs from the host container, application logs, all the metrics, processes running inside the containers, outside the containers, and some things like Kubelet metrics as well that helps you to find where you're spending your time when you're trying to launch something in OpenShift. And the third thing is just a single instance deployment, we call it add-on, which allows us to collect things in just once, like for example, Kubernetes events, or if you're running a etcd cluster on dedicated nodes as well, you can define it here as well. So let me actually go to the demo now. So in my demo, I actually have 2 OpenShift clusters running. I call them development and production, pretty much as a lot of other people do that. And so this is Splunk Enterprise with our application installed already. And as you can see, this is the first view we give. And we're kind of trying to set up our applications for 2 purposes. One for usage by the developers and another one for operators. So for developers, for example, they don't really interesting about the host and like the cluster setup and everything. They only like interesting in how where their application are running, how they're running, and like just they want to monitor the application. So this is basically a view for developers where they can go and see all the projects they have access to and all the workloads and applications running inside of OpenShift, all the events happening in their cluster. So from here, you can basically drill down from the project basically even to like processes. So let's take a look. One of the examples can be like SockShop. SockShop is how it's called, View Network demo of like multi-service demo for the Kubernetes, and which you can run on Kubernetes and pretty much any other orchestrations. So as you can see, after I drill down to this project, I see all the deployments I'm running on this project. If you will have like cron jobs or daemon sets, you'll see them here as well. From there, you can, for example, drill down to one of the workloads, and this will be deployment front end, where you actually will see all the pods running in your deployment, all the like metrics, CPU, memory, IO, all the containers, processes running inside of them, and logs as well. You will get them here. So as you can see here, I actually scaled up my workload to plus 2 more pods. So you don't need to preset up or anything. Every time you scale up or create the new workloads, they automatically will be picked up by us and forwarded to Splunk. And so from here, you can always drill down, for example, to pod to see the information about the pod and list of containers running, processes in this pod. If you will set up CPU quote and CPU shares or limits, you'll see them on this dashboard as well. This pod doesn't have any logs. And so from here, you can actually drill down the container to see information specific about the container, but this pod doesn't have multiple containers, so maybe it's not so interesting. But from here, for example, you can drill down to the process metrics. And in process metrics, you can see pretty much any information you can get from the file system. We're also trying to make sure that you are not going to be lost in this dashboard, so we provide the help to understand what you are actually looking on. And again, like use CPU, like all the, for example, context switches, number of threads running in your applications, all the various virtual memory. You will be able to see where you how the memory is allocated. Some information about I/O, like even syscall, so everything will be pretty much here. And let me actually now show you, as I said, like the different view on the on your cluster is you can, for operators, they in most cases they want to actually see the whole cluster, all the things you're running in your all the nodes you're running in your cluster. So in my case, currently I have, as I said, two clusters, one development, one production. And so what we do, we recommend actually to define the node labels to be able to actually distinguish this cluster. So let's say if I want to see my production cluster, I can just filter and see all my 7 nodes from production cluster. If I want to just see development cluster, I can always again filter and see only developer cluster, which has only 2 nodes. Or at the same time, for example, if I want to find the master, I can do that as well by using the labels. So on this view, you actually will get the list of hosts, again, like all the metrics, events, if there are some warnings, for example, I haven't finished setting up the Ansible service broker, and the host logs as well. So you'll get them here as well. So from this view, again, like you can drill down pretty much to the process level as well. And for example, I can drill down to the host level and see detailed information about this specific host, this list of ports, like the memory, how it's allocated for the specific host, and I can see all the containers running on the host, including the containers scheduled by the OpenShift and other containers as well. So for example, if you are running OpenShift in containers, which are actually scheduled with just Docker, with not OpenShift, you'll be able to monitor them here as well. And you'll see all the processes running on this host, even like all the host logs as well. Like in the case of syslog, for example, you'll be able also to see like specific components and filter by them. So as I said, like from here, you can actually drill down from the pods, containers, processes, and so on. We also provide for you really like easy to use to monitor multiple clusters or multiple nodes views, like top-like views, we call them that way, to see like all the some containers which are using the most CPU at this moment, and so on. So for the cluster health and like monitoring the health of the clusters, we provide a lot of views. For example, this is the first view I was going to show you. It's audit logs. So from this view, you can actually see who, when, and why changed things in your cluster. So for example, I can drill down to the admin username, and actually you can see that this is where I scale up my cluster. So you can actually like by the operation find that, you know, like when I was trying to watch on this namespace and like what I did in this moment, and you'll get pretty much all the information from about that. You also will be able to see from where I did that. So this is actually my IP address or my network. I mean my internet provider. So you'll be able to see that as well. And if there's some issues with access, you will be able to see them as well. So for example, some reasons probably when I was browsing something from the web page, I get fault for one of the API calls. And other things like the control plane metrics like API server, so you'll get them out of box here as well. So in my case, because I have 2 clusters, one production cluster with 3 masters and one developer cluster with just 1 master, so I can see 4 nodes running as masters and the metrics from 4 nodes. And so again, like I can actually see who is calling my API cluster, and if maybe there's something which is calling my API masters too often, I will be able to monitor that, and I'll be able to see the performance of my API API servers as well. So another thing is the controller. So this helps you to know how quickly things are scheduled in your cluster and if there are any issues with that. So I rarely actually see our customers looking at these dashboards or like trying to find any issues with it, but sometimes it can help as well to at least start looking at some problems. Kubelet can give you information about how your OpenShift cluster working on every node with the Docker. So where you're spending all the time. I mean, it's usually everything is pretty tiny. It's like microseconds, milliseconds. But for example, if you see the longest operations, they usually pull images, right? So you'll be able to see them here as well. And things you can actually debug here is like how long it takes to terminate the instances, and like maybe how long it takes to mount the volumes. You'll be able to also see either any errors here. You'll be able to monitor them up here as well. So Kubelet, we provide metrics for every node because every node is actually running its own Kubelet. And if you are also running etcd cluster, and you actually collect a metrics result, then you will get this dashboard as well. Again, like in my case, because I have 2 clusters, one with 3 masters, one with just 1 master, I'm being able to actually see the metrics from 4 members. And again, we provide the information, all the important information you need to monitor the etcd clusters. And at the same time, we are providing some help so you can actually understand what you're looking for and if there's anything you actually need to do to with this information. Another thing we do is we're trying to provide the help how you can monitor the, for example, allocate the resources, and this is capacity planning, right? So you can actually take a look on all the resources available on your clusters, how much CPU requests you already made, how many memory requests you already made, and what the total amount is, what's the current CPU limit, and so on. So you'll be able to see that as well. Per every node, you'll be able to see that. And like in my case, my clusters are pretty small, and that's why if I will try to run pretty much everything on 100%, some of my nodes probably will fall down because, as you can see, I already limited in total on some of them 100% and more. Another important thing is this is the how much memory you are reserved for your system components. So let's say, for example, you are bootstrapping your cluster and you're running etcd servers on the masters. And if these masters, for example, have 16 gigabytes of memory, if you say that this master actually have allocatable like 14 gigabytes of memory, this means that if you actually try to allocate everything with OpenShift, there's not a lot of memory going to be left for system component like etcd cluster, and basically just any other things running on the system which not part of OpenShift ports. And so we're trying to make sure that you actually give this enough of the memory to these components. And you can see again, like in my test environment, I didn't. And things can go not well if, again, like most of my ports will try to use memory close to the limits, and this actually can break my deployment. So we're trying to help with that and provide some guidance as well. So you don't want to see red in your deployments. For security, we provide some information about all the privileged containers and all the enabled capabilities in your deployments. Like, again, as I said, our collector actually are running as the root because it needs a lot of things to get all the metrics and just give access to the logs. You can always work and try to limit them. But in this deployment, which I got from Sockshop, it's actually using the Kubernetes service. So this means that This is the capability that allows the process to bind to the ports from 1 to 1000. And you don't really need that in the containers, right? You can bind, for example, to 8000 and after this mount this port to lower one. So this is probably something you want to revisit. So this is a really quick overview. There's just one thing I want to show you. Like again, like if you're familiar with Splunk, if you will try to see all the logs from the containers we forward to Splunk, you can find that all of the logs actually enriched with the OpenShift specific metadata, node info, all the different type of deployments, their names, container names, pod names, all the labels, and so on. So you can always quickly find the right information. Okay, so let me go back to slides.
Dennis, can I ask a couple of quick questions that came in?
Sure.
We go back to the slides. It was looking, one of the folks on the call was asking, can this give me alerts on failed nodes? If, for example, one of my masters failed, could this detect that connection and alert me? Alert?
Sure. Yeah, this is a good question. So what we don't provide any alerts by default. I don't really know how well how experienced this customer with Splunk, but I can show you a quick demo. So we don't really have any alerts about predefined alerts because Splunk has a lot of capabilities to alert you, and we don't really know what kind of like trigger you want. Do you want to send email, or do you want to send the notification in the Slack channel, or hip chat, or something like that? And so what you can always do, let's say you open this search in a new tab, right? And after this, you'll add something like search and I want type, for example, not normal. So anything not normal, if you will get any result here, you want to alert on this. There's nothing here yet. And so what you can do, you can save this as alert. And if it's at some point you actually get this not normal warnings, you're going to get an action. This is default actions like webhooks, send emails, transcripts. You can add a lot more on a Splunk base. There's a lot of other actions you can add. So you can predefine your alerts and monitor things like lost members and so on.
And I think that answers Paul's question. He'll tell me in chat. Someone else is asking, how can he find the live pods he currently has?
How we can find what?
The live pods that he currently has.
Live pods that it currently has. So as I said, like for example, you can drill, like if you know that where you're running like a project or namespace, you can always go there. But in other options, for example, you can go to the list of all pods currently running in your production, right? And you can always search here. So again, like if you know the node labels, you can do that. If you know the pod labels, you can find it. If you know the projects, you can filter it, and you can always filter, like, for example, do you have, oh yeah, I have some MongoDB, so for my Node.js application. So I found the pod, I can go there and find the information about the pod and start seeing monitoring this pod right away. Hope this answered the question.
I think it is. But what he's asking is, how can I filter on nodes that are on the nodes that are only currently up?
So we do not, like if there are some hosts which are down, you will not see them in Splunk, right? Because we actually, what we do, we run our collector as part of OpenShift deployment. And so, for example, if you have like cluster of 6 members, you'll see all of them in Splunk if you're actually running them. If one of them will go down, we will not be able to collect the information from this node, right? But at the same time, you actually will get an event, you will get an advance from the master that there is a lost member of the current cluster.
I think that answers his question. So let's go back, jump back into your slides, and let's continue.
Yeah, I like the questions. Thank you for the questions. This always helps me, like if you actually give me the right demo because again, like I don't really know how the expertise of the current like people who are actually watching this is how familiar with the Splunk and so on. So it's useful. Questions are useful. So back to the slides. So now I actually want to drill down a little bit to like close to product, like close to like real environment. So a lot of cases, our customers want to limit the access to the data. Let's say, for example, operators want to see all the host logs and all the information running on the from the host, like the health of the clusters. But developers, maybe they didn't want to, maybe they're not allowed to see that. And you want to actually define that developers should be able to see only information from the specific for their project. So we are allowed to do this. What you can do, you can annotate the project's namespaces with the defined annotations we have, which allows you to override the indices, sources, source types, pretty much anything, like any specific, like the main field, how we call it, fields for the events in Splunk. And you can set this annotation on the level of namespace or workloads or even pods. So you can do that as well. So one demo I can show you is of this user that actually have access to just one project called SockShop. And as you can see, this is the same overview for the same cluster. And he actually have, he only see this one project, SockShop, and he can only drill down to this SockShop project and see all the deployments in this SockShop project. But if he'll try to, for example, go to the list of hosts, he will not be see any information because he doesn't access to this indices. And really quickly, I can show you how it can be done. So if you go to the Splunk settings, and I have this user that just regular user, and it's part of the user role. And in this user role, for this user role, I actually gave this user only access to the specific indexes, and I forward all the information from the this project SockShop only to these indexes. So he has access only to these indices. So this is the reason why he cannot see any other data. So it can be useful in the real production deployments. And I found that a lot of our customers actually do that. The other things are some information about container logs. And this is, I think, like a really cool demo to know a little bit more about Splunk itself and to show you capabilities of our solution as well. So every time when you forward, we automatically forward all the logs from the containers, right? And we actually preset up this special source format where you can, which we construct for all the various components of the pod, which includes container ID, container name, image name, pod name, namespace, and Docker stream. And so let's say you want to get the logs from the container that are using the latest Nginx image. Never use latest in production, but like let's say you do that, and in default project on namespace, you can actually say like, hey, my source type is OpenShift logs and source with a wildcard. So you actually define the things. You say like, hey, I want from every container ID, from every container I want, but I want to make sure that this container is using Nginx latest image. Or let's say you want to get logs from the container's name proxy, and then Nginx image can have any tag. You can do this again with wildcards. Or again, because I showed that we actually annotate all the events in Splunk, you can also use different approaches for, like, for example, namespaces. You can actually do it with sources as well, but you can also use with the metadata we attach. And another example, like deployment name. You can say, I want to all the logs from this OpenShift deployment name front end and OpenShift namespace SockShop, and you'll get all the logs. You can find the more information on this link, and yeah, we'll share with you all these slides, so you'll be able to find these slides and links later on. So let me actually show you the power of Splunk and how you can actually use this knowledge of the sources to build your custom dashboards. So let me go to the admin user, and I have monitoring OpenShift application. I have this Node.js demo applications that I'm running. Actually, currently I'm running some workload on this application which generates some logs, and just for the demo purposes. So this is Node.js application which has the MongoDB and some front-end application Node.js, which is just Node.js. Several pods, and at the bottom, as you can see, there are logs. So let me actually open these logs and start working with them. So first thing I can do, let's remove this heads, and this is basically the native experience what Splunk gives you information about the events in your Splunk. And so this is where I started to actually run my workload. As you can see, there's 209 events every minute. On the left, you can actually see metadata attached to this log. So if you want to really quickly drill down on specifics, you can do that. But as you can see here, I have 6 sources, right? So the workload is load balanced, and it's actually really well load balanced between all of the 6 pods. So if we will choose just one, right, I will actually see the logs only from one, and this is not what I want. What I want to do is build a dashboard from all the pods. And as I show you above, I actually don't need the replication control ID for now. I can use this wildcard to say, like, hey, container ID, don't care. Node.js, this is the this is fine. This is basically the container name. I can keep it because all the containers named the same. A pod name, they all have different pod names, so I don't care. I can use wildcards. So I get back to the view of my 6 pods, and so why I'm so curious about the sources, because now I can use this knowledge to actually how to get the logs from all my pods, and I can start extracting the fields. So this is basically how Splunk is differentiated from a lot of other solutions that requires you to actually define the schema when you index the data. Splunk allows you to pre-index some data, like for example, our metadata we attach to logs. But after this, you can actually work with already indexed data to start extracting more fields and build the custom dashboards or things that you actually care about. Let me actually show you an example. What I'm going to do, I'm going to go to the fields and field extraction, open field extractor. I'm going to use source, and I'm going to use this the filter which I use with the wildcards and so on. So it gives me an example of all the logs I'm actually getting in my Splunk deployment. So I will choose one as an example, go to the next, and I have 2 options. I can define this as like CSV type file where you like there's spaces, divide the things, or I can use regular expression to extract the fields. So I feel like confident that I can do it with regular expressions, but the thing, you actually don't even need to know regular expressions. Splunk gives you a really good UI for extracting the fields. You can just select it and say like, hey, this is like request timestamp. This is the request verb. This is, for example, request path. And I like response status. So let me get the last one, user agent. So you get the feeling, right? So you can just using that start to extract the fields. As you can see at the bottom, you can verify that everything is extracted as you want. So the path is a little bit more complicated for the reason I will show you in what you can actually do with Splunk search as well to extract even more complex data from the things you already extracted, right? So I'm okay right now with what I have, what I see. So I extract the verbs, request path, response status. Let's say I don't care for now about other data on these logs. So I'll go to the next view. I verify that everything is correct. I can actually even take a look. No matches, meaning like, is there anything that, like I define as regex? Is there any logs from my source which I define as a filter that do not match that? It's possible that there can be, like, for example, when I start Node.js, it actually prints out some of the not bad logs, but like some information about this starting the process and they will not match. It's fine, right? So it's like, they're not useful for me because what I wanted right now is get information about the web request. So the last thing I need to do, I finish it, I saved it, and now I actually explore this field and search. So now actually, like the simple thing I can do, time chart count by request verb, and start building some visualization, right? So I can go to visualization and actually see all the, let me actually drill down to like 4 hours, right? And I can see things was happening for the last hour. I can even change like span, then 1 minute to be more accurate. So for every minute, I can see all the requests and where they, how they're actually going. I can also do a lot of the various type of graphs, and I can actually do stacks. So like you can actually compare all the different. So I do a lot of gets, I do some posts and few deletes. And what you can do, you can actually now say, I'm gonna save this as a dashboard and my web app, and keep it short in the application, so everybody will see that. So let's save that. We get the first view on the dashboard. And let's actually start populating more data in here. So now we get the get, delete, post. So I already mentioned that what's really interesting about this data, like the request path is a little bit more complicated. So for example, if you do request path, right, it actually has the query parameters, this Q equal like as a question, right? So what we want to do, we want to extract this data as well, and maybe build some dashboards to see like what questions user ask in our in our application. So maybe we just can do some statistics on this. So for that, actually, I saved the search to save your time, but let me actually go and show you pretty much every step I do. So head 50 is just for debugging. I want to get only first 50 to see the results that are needed in this demo. So first thing we do, we actually URL decode this data. So actually, let me show you again a table. So like before, you actually saw there was the URL was encoded, so we decoded to make it more user readable. So we did that. Next thing, we actually extract with regex again. We extract the question. It's easy to. You can actually, in this simple example, you can do maybe even with the just string substitution. You can actually just say like, sorry for like index 4. This is my question, and so you can now define the table. That like as you can see, we extracted the question. So let's work a little bit more on that. What we can do now, we can see stats. Actually, stats count, question, count by question. So we can actually now see the statistics by questions. Yeah, one thing we can also do and say, we only want to find data that actually have a question. So that's that. So that's also top. So we should also give you count and percent. And depending on your preferences, you can always, for example, do like scales, like for the percent, so you can actually distinguish the data. Or you can again go to visualization. Everybody likes pie chart, so you can actually build the pie chart. And another thing you can do, you can save it to existing dashboard, which we just created. How I called it, something like web app, right? I'll call like questions. And here you go. Now you actually have the dashboard, which also showed the all the different verbs and also all the questions running in your application. As you can see, with the power of Splunk and the SPL is Splunk processing language, and with the capabilities of building the dashboards, you can actually start defining your own dashboards. And you can edit these dashboards, you can actually convert to JavaScript and start using JavaScript to build the more complex views. You can even add the filtering as well here. And you can actually combine the dashboards, so you'll be able to drill down from one to another. So when I show you our overview of our application, it's basically just a set of dashboards. We don't have any more specific than that. We actually basically just use this way of constructing dashboard and we build our application. So hope that can give you some overview what Splunk is useful for, and some capabilities you can get from out of Splunk. And there's much more. There's like machine learning toolkit that allows you to predict something, some things that if you can build this on your data, and a lot more. So let me actually go back to the slides if I have anything else left. So I gave you a demo of custom dashboards. Some things about the pricing. So for a Splunk, I can just say that the pricing depends on the ingesting volume. So you kind of need to know slightly about like how much data you're going to ingest in Splunk. And for our pricing, as I said, we actually different company that provides the solution on top of Splunk. We price based on the monitoring nodes, and starting from 300 and all for 5 nodes. So like if you want to get, for example, get familiar with Splunk and OpenShift, we find that it's it can be useful to just start with us, because you will start getting the data, you can explore the data, and you always work with us if you have any questions. And that's my last slide. So I hope you enjoyed our demo. If there's any more questions, I'm here to answer, and you can find more information about us at outcloudsolutions.com, all the instructions, how to install our solution, and all the information, all the demos. You don't need to contact us if you want to try it. You can just download it right away, and it takes 5 minutes to set it up. You can also follow us on Twitter if you want to see all news about us. So I'm open for questions.
Cool. Well, thank you very much. That was pretty, it's wonderful to see that much of Splunk. I don't think I've looked at Splunk Enterprise in a long time, so there's been a lot of really great new features added. There was one more question that's floating in. How can a simple user add multi-line settings for their specific data?
That's a good question, actually. Let me actually try to find, if I can, an example. So by default, our collector actually trying to predict the multi-line logs. So it's like it's a real problem if you experience Docker user and use it for a while. It's like a real problem actually if you have multi-line log lines. They will be split by every event. It's actually happening pretty much on every Docker driver, Splunk login driver, and it's CloudWatch as well. Pretty much all the solutions have this problem. So we solved that by merging this back together in one event. So let me actually try if we will be able to see that. If I'll be able to find it OpenShift logs. What the source type too. Maybe I can see some partners. Oh wait, so this is my this is the administrator. Yeah, probably I don't have this right now, but basically what we do, if we see that there's if we see that you have the lines which start from the space, we basically just glue it together with previous line. And so you always will be able to, you don't need to do anything specific here. If you have more complex logic, for example, if you know that your lines always start from the timestamp, something like that, you can define that as well in our application. And we have documentation which covers pretty much all of that information. You can go to our website, to our docs, and find information how we do that. Like in case of OpenShift as well, you can find how we do that. So there's like join rules. You'll need to define it with regex to define more complex rules. So for example, in this example, this rule will be automatically merged, but if you want to get this as one message, then you actually will need to define your own rules how to join events together. Hope this answered the question. I should probably make it larger as well.
I think so, and if it didn't, it did just point out where all the documentation is, so that's a great starting point. There's one more question, which is probably a question that could be a whole briefing in and of itself. And so you don't have to try and demo this because we only have about 8 minutes left. Mm-hmm. But what is an example of using the ML toolkit in Splunk? And have you been using it?
That's a good question. So yes, it's a really hard question. So Splunk has a lot of demos how you can use ML toolkits. I mean, we don't use it currently in our application because using ML toolkit requires you to have more knowledge of like what you're trying to predict, right? And I mean, in our cases, like how we can apply it to our monitoring solution. We can start predicting that maybe you'll soon get out of resources in the way how you schedule things on your cluster, right? Maybe we can do it here, but at the same time, it's pretty easy to tell you without even machine learning that you're getting close to hitting resource limits, so maybe you should expand your cluster, something like that, right? More complex things around the features or like web logs that like maybe a part like if you for example you will use your web application that and maybe there's sometimes patterns happens that the flow of users can increase, like the number of users can increase because maybe there's some popular blog post published somewhere, and then maybe there's like specific patterns where like the increase of users, and you can actually want to make sure that you'll predict that, and again like increase the capacity of your clusters to actually being able to hold this. So there's a lot of use cases. We do not currently use it in our applications because we need to really weight it, like really, why do we really want it? Is it like really useful? And so we don't do it right now, but there's definitely like we give you all the data from your cluster, so you can definitely take a look and see maybe there's something you can do. So I hope this answered the questions.
Yeah, that's helpful. Thank you.
Mm-hmm. So any more questions? Georgiana, I do not hear you. I don't know where.
Yeah, I muted myself. I think that there's some other folks from Splunk who are on here too, and I think we can coerce them into doing a deeper dive on ML and Splunk and get their folks.
Yeah, so for example, I know there's Splunk Lives happening pretty much in every city. I mean, in a lot of cities, and so in Seattle, if you're, for example, in Seattle, there will be a Splunk Live in a week or two in Seattle, so you can probably find on Splunk.com, and some of the topics will be about the machine learning as well. So if you're in Seattle, join it. If you're in another city, please follow the Splunk Live, and I think it's the free event, so you can go there and just learn more from the Splunk experts and the most knowledgeable people in Splunk.
Awesome. Well, thank you very much. Usually I try and get people to do just a half an hour because it's not that, people won't watch the whole thing, but I think for once the content that you're delivering today is just was very good. So thank you very much for this. Obviously, we need to do more Splunk talks, and we'll be tapping you and If you can pop into the Slack channel afterwards, Dennis, I think there'll be a few more questions as well.
Sure.
People doing.
I will be available there as well. Yeah, you can find me by the nickname of Coleman anytime. So I'm on Slack channel and I will be there as well today.
Perfect. All right. Well, thank you very much again for today, and thanks everybody for coming. I'll have this up on YouTube hopefully by midday tomorrow, and we'll share the slides as well. So thanks, and great to have you as part of the OpenShift Commons, Dennis, and welcome.
Yeah, thank you for inviting me, and it was a pleasure to show you demos.
All right. Take care.